Hello. In this video, we're going to go over sketching the graph of this function. To recall when we sketch the graph of this function, what we need to know is the degree, the highest degree, the leading coefficient, and the zeros. Once we know that, we will be able to graph our function. Let's set up our graph. And we'll begin. Perfect. So first, the highest degree is the number with the largest exponent. So our largest exponent in this equation is 3. Our leading coefficient is either positive or negative. We can see the number in front of x3 is just a positive 1, so positive. What we have to recall, what we have to recall are some of the rules of end behavior. When the degree is odd and the leading coefficient is positive, we know that the end behavior acts like this. When the degree is odd and the leading coefficient is negative, we know that the end behavior flips. So we have this end behavior for our current equation function. Next, what we need to do is find the zeros. To find the zeros, we need to factor. We have 4 terms, so the hint there is we need to GCF it and do grouping. The first is I'm going to underline both terms. The first group I can see I need to take out an x squared, so I will do so. I pull out an x squared, and what is left is an x minus 3. Next, I'm going to pull out a negative 4 here, and I'm going to get an x minus 3. Next, the next GCF you should see is x minus 3 pops up twice. We have x squared minus 4 and x minus 3. Next, we can factor x squared minus 4 more fully because that is a squared minus b squared, which is a minus b times a plus b. So this will become x minus 2, x plus 2, x minus 3. Set this equal to 0 because that's the whole goal of everything we've been doing, this whole function. And then we're going to see that x is equal to 2, negative 2, and 3. Those are my zeros. We go to the x-axis and we plug dots on those points. 2, 3, and negative 2. Next, we need to talk about the multiplicity of each one of these zeros. When the multiplicity is even, we have a bounce. When the multiplicity is odd, we have a cross. Here we can see that each one of them only pops up once. So that means they all have the multiplicity of 1. Therefore, they are all a cross, cross, cross. So next, I see my zeros. I'm going to plot my end behavior near the zeros just to make it kind of clean. We're going to start from the left. We're going to cross, bring it back, cross, bring it back, cross, and connect to our other endpoint. I didn't make that perfect, but the gist is there. Let's do that one more time because that was not a great drawing. Cross, cross, cross. There we go. So there we go. And that is a sketch of that function. So again, the 3 things we need is the degree, the leading coefficient, and the zeros. I will be doing another video, more videos on this, one with an even, one with something that's already factored as well.